Okay, today we are going to be talking about mental multiplication. Yesterday we did some multiplication properties that are going to come in handy today as we're talking about this mental multiplication. In your table of contents, go ahead and fill out, this could be number 6 or it might be a different number for you, I'm not quite sure. But make sure you get that put in your table of contents. Remember, at any time during the video, if you're like, man, I need to get this written down, please pause the video and then press play again. Don't just speed through the video. You need to make sure that you're understanding what I'm saying. Just like if I was teaching in front of everybody, this is your personal teaching video for you. So make sure you're getting everything written down. So the next clean and clear page, you're going to put the title on there, mental multiplication, and our I can statement. I can mentally solve multiply. That should say multiplication. Let's fix that. I can mentally solve multiplication by multiples of 10, and we're going to find out what the word multiples mean here in just a little bit. So let's start with this to kind of get our brains all warmed up. Some addition calculations are less challenging than others. So if we had 3 plus 3, hopefully as 5th graders we can tell that 3 plus 3 is 6. But the important part of that is we can use this information to help us solve something that might be a little more challenging, like 3 plus 30. 30 plus 30 is what I meant. Well, we still have the 3 and the 3, and then we have some additional zeros, so we would have 600. We can also use this if we were to think about 300 plus 300, where we use that front 3 and 3, and it gives us that 6, but then we just drop our zeros at the end. We're going to use that concept today, but we need to write down a couple of important vocabulary words that we will be using throughout multiplication. A factor, these are numbers that are multiplied to get a product. Factors are important because sometimes we can find common factors. So this, the 2 and the 3 are a factor to get 6, 7, and 4. These are factors to get 28. These are our factor pieces, the numbers that we multiply. The next vocab word is product. We should know this one, but I wanted to review it just in case. A product is an answer to a multiplication problem. So in the ones that I just drew here, this is my answer, so that is my product because we are multiplying in these number sentences. So 28 is my product here, and 6 is my product here. The last word that we have here is multiple, and multiple is the product of a whole number and another whole number. So this is the product of 2 whole numbers. This is the product of 2 whole numbers. That means they are multiple. Make sure you get all of these words down. We will be using them throughout our multiplication ordeal, but you need to know, if I talk about a factor, that means the 2 numbers that multiply to get a product. And if I'm talking about a product, it's the answer to a multiplication problem. And if I'm talking about a multiple, it's the answer to a multiplication problem, but in a specific order. I forgot to draw what that would be. So if I wanted to do multiples of 7, I would say 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is, challenge, 28. I just did that one up there. That's silly. 7 times 5 is 35, and it would just keep going. These are the multiples of 7. All right, so suppose you can sit 3 people at a table. It's a small table. Only 3 of them can sit there. That's okay. How many people do you think that you can sit at 2 tables? If 3 can sit at 1 table, how many can sit at 2 tables? We could do 3 plus 3 and get a total. But when we do repeated addition like that, it's also called multiplication. So if we have 2 groups of 3, because 3 is our group, we could have 6 people. So at 2 tables, we can fit 6 people. But here, now they're asking how many people can we fit at 20 tables? That's a little bit different now, because we have 20 tables, 20 groups of 3. Ooh. I'm going to use this question that I had before here, or this problem I had before, and say, okay, 2 times 3 was 6. Here I see a 2, and I see a 3 when I have this 0 on the end. 0 is one of those great numbers that when I multiply by it, it equals 0. So when I try to say, okay, I'm going to have 20 groups of 3, I could use my repeated addition and go 3 plus 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 3 20 times. Or I could use this problem that I did up here before to help me. I could say 2 times 3 is 6, and then that 0 on the end of the 2 is going to give me an extra 0 here. So I use this pattern. 2 times 3 is 6, 2 times 3 is 6, and then I added an extra 0. Next one. What about 200 tables, or 200 groups of 3, because that's how many can sit at the table? Well, we're going to use this pattern again. 2 times 3 is 6. 20 times 3 was 60, because we did 2 times 3 and a 0. Now we have 200 groups of 3. Well, we have 2 zeros here, so we're going to take that front number 2 and 3, multiply those two, and get 6, and drop our other zeros. We can see that this is a pattern that goes on, but the front numbers is what we're using, the 2 and the 3, the 2 and the 3. If we ever get stuck with something like this, we can use those patterns. So if we had, let's say that we had 600 times 400, we could go backwards in our pattern and say, okay, well, what would 660 times 40 be? And if we can't go there, then we would go even further and we would say, okay, well, what's 6 times 4? Let's start basic and do 6 times 4 and work from there. Well, 6 times 4 is 24. So then when I bump up, I could even put something in between there and just, okay, let's do 60 times 4 first. Well, I know that it's 24 and another 0. Then I could bump up here, because now I'm adding this 0 here. So we'd still have 24. And then finally we could get all the way up top here and do 24, because the 6 and the 4, and then add those zeros and put our comma in. We could always use the patterns like this to be able to solve problems that end in zeros, multiples of 10. The properties that we learned about yesterday can help us with mental math too. We talked about this commutative property. Commutative property means that I can flip-flop the numbers like, oh, I don't want green anymore, I'm on a white screen. 2 times 4 is the same thing as 4 times 2. I can move them back and forth. Associative is how I group the numbers, like or I could do group them like this. Then I could also use the identity property, which means I'm multiplying by 1. So if I have any number times it by 1, it's going to be that number. And then the 0 property that says, hey, anything that I multiply by 0 is going to be 0. Let's use what we've talked about so far to try to solve these problems. This first problem that I have here is 50 times 32 times 2. Well, I really have, I would have to use a lot of brain power to be able to do 50 times 32. Number one, because 32 ends in a 2, so it's not easy to multiply like this 50 is. But I see this lonely 2 hanging out here on the end, and I can think, hey, I'll use that 2 first. I'll say 2, and which one would be the easiest to multiply by 2? Well, 50, because it ends in a 0. Numbers that end in zeros are easier to multiply. So I use the commutative property because I moved that 2 to be right next to the 50. And I also use the associative property because I'm going to associate these two first. 2 times 50 equals 100. Oh, look, another number that ended in 0. So now I have to come back here and use this 32. Well, I can use the identity property because these zeros right here are going to lead to a 0, 2 zeros out here, and 1 times 32, identity property says it's going to be 32. So we use mental math to solve all of that to get to 3,200. We use the commutative property to move these two next to each other and then associate them together. And then I use the identity property to be able to tell, hey, that's going to be 32. So I'm going to move this so that I can get some space because I need to do this other problem, and I wrote too small to get this other problem fit in there. So I'm going to just put the answer of 30 that we got for this one. And I'm going to move on to use my properties over here. Well, any number that ends in 0 is going to be easier to use. So I'm going to use my commutative property to move my 10s next to each other. I'm going to worry about this one later. And I'm going to say, okay, well, 10 times 10, here's the identity property because I'm going to times by 1. And then I'm going to put those zeros in there, drop those zeros down. Now I need to multiply by this 783. Well, here's that identity property working again. 1 times 783 is going to be 783, but then I have to include these zeros. Boom. Got it solved using mental math. Let's try another one. This one I have 150 times 20. This one I could use a pattern on, and I could take off those zeros and say, okay, 15 times 2 equals... And then I could say, well, 15 times 20 equals, and then I could say 150 times 20 equals. So let's start with 15 times 2. That's probably not one that we can do in our head. We might need to write it out here to the side. Let's say, okay, 5 times 2 is 10. 2 times 1 is 2, plus 1 more is 3. So 15 times 2 is 30. As I travel down here to this next one, I took and added a 0 here. So on the end of here, we're still going to do 15 times 2, but on the end of the 30, now we're going to have another 0. So now I have 300. And then I came down here and I added a 0 to the 15. So now I'm going to have still 15 times 2, but then I have 2 zeros, one from the 20 and one from the 150. So I have 3,000. 3,000 is my final answer here. Let's try another one. Here's a 500 times 40. I'm going to look at the front numbers here and go backwards and say, okay, well, 5 times 4. 5 times 4. Think. 5 times 4. What is it? 5 times 4 is 20. Then I'm going to say, okay, well, what's 50 times 4? I'm going to add an extra 0. What's 500 times 4? And then I have to add my last 0 in the original problem, 500 times 40. We're using that mental math to solve a simpler problem to be able to find the final answer for this big problem. This one I'm going to use okay. I'm going to use my properties to be able to solve this problem. Now I could go all the way back and shrink this down and do 18 times 2, but I want you to look at this very important fact right here. I have a big goose egg here, a 0. When I have a 0 in times any number, the answer to that problem is going to be 0. So I'm going to actually use my 0 property and my associative property. So I'm associating this 20 times the 0, and when I take 20 times 0, of course, I'm going to get 0. So I use both properties, and now I finish my question. I have 0 times 1800. Using my 0 property, times it together, I'm going to get 0. So that very long problem that looked kind of complicated ended up to be not so complicated because of that 0 property. We have one question or one problem left to work through before you get to work on your own. This question says Google, I guess, Google is a large number that is the, it should say, that is the digit 1 followed by 100 zeros. If you multiplied a Google by 100, how many zeros would the product have? Well, let's be honest. I don't want to write out a number that has 100 zeros, but they're just going to keep going all the way. I know that I'm going to have a total of 100 zeros with the number 1 in front of it. Well, if I took that and I multiplied it by another 100, I'm going to take these extra zeros from the 100 and add on to the end of it. So I had 100 zeros, but then I'm multiplying by another 100, which gives me 2 more zeros. So I have 100 zeros plus 2 more zeros. How many total zeros will I have in a Google? 100 zeros plus 2 more zeros. Not necessarily tagged onto the end, but 2 zeros is going to be 102 zeros. When I multiply by another 100, I have those 2 zeros in there. Okay, that's the end of my video. Hopefully you understood all of those things. You got all of the notes written down. You're going to move on over to Schoology and find the assignment 3-2. It is due by Monday because you don't have school tomorrow. So go ahead and get that taken care of. And as always, happy mathing.